Let us recall the previous knowledge. What is meant by a prime number? What is meant by a composite number? Okay. See these slides, my dear children. In these slides, let us recall through these slides. Are you able to watch the screen, my dear children?
No, sir.
Are you not able to watch the screen?
No, sir, it's black color.
Yes. Okay. Okay. I will check.
It's not visible, sir.
I will check. I will check it. I will check now. Now, are you able to see the screen?
Yes, sir.
What is there?
Different methods
Different
of
methods of
finding prime
finding prime
numbers.
numbers.
Yes. Today, the main concept, the main topic is how to find a prime number. Okay. But we are not going directly how to find a prime number. We don't discuss that point directly. First of all, let us discuss what is meant by prime number. Okay. See here. See the definitions of prime numbers and composite numbers, my dear children.
Yes, sir.
Yes. So this is first this one. Prime numbers, the natural numbers which have exactly two factors are called prime numbers. See the definition, my dear children. See the definition. Prime numbers, the natural numbers which have exactly two factors are called prime numbers. Now the exact definition of prime numbers, see this definition, my dear children. A positive integer p is said to be a prime number if p greater than 1 and p has no factors except 1 and p. That is, do you know this symbol, my dear children? What is the meaning of this I dot E dot? Do you know meaning of I dot E dot?
Yes, sir.
Yes.
That
What is the
is.
meaning? That is, yes. The meaning of this
That
symbol is
is.
that is a natural number which has exactly two different factors. Okay, my children, p itself and 1 is called prime numbers. Okay, my children, this is definition of a prime number. For example, 2 comma 3 comma 5 comma 7 comma 11 etc. are some prime numbers. There are infinitely many prime numbers are there. The first and foremost prime number is 2. Okay. Note, Fermat proposed that the numbers of the form 2 power 2 power n 2 power 2 power n plus 1 are prime numbers. If any number is in this form, then he said it is a prime number. However, it is true when n is equal to 1, comma 2, comma 3 and 4 only. But This formula is suitable when the values of n are 1 or 2 or 3 or 4 only. If you take other than these 4 values, that number may not be a prime number. Who proposed the numbers of the form 2 power 2 power n plus 1 is a prime number? Listen this one. Fermat, a mathematician. Okay. What is a prime number proposed by Fermat? 2 power n plus 1. Remember this formula. And this formula is true. This formula is true when n values are 1, 2, 3 and 4 only. Okay, my children, remember this point. Now come to the next type of numbers, that is composite numbers. The natural numbers which have more than 2 factors are called composite numbers. For example, 4, 6, 8, 9, 10 and so on. All these numbers are called composite numbers. Okay, my children?
Okay, sir.
Yes. Now come to the observations. We can observe these following points. What is the first point here? See, 4 is the least composite number. 4 is the least composite number. And the second one, all even numbers are composite except 2. Even though 2 is an even number, it is not a composite number. It is a prime number. Please remember these points, my dear children. In examination, they will ask you which of the following numbers is a prime number, or which of the following numbers is a composite number. Like this, they will give some options. You have to identify which numbers are prime numbers and which numbers are composite numbers. And next, third observation, third point, 1 is neither prime nor composite. The number 1 is said to be neither prime nor composite numbers because it has only one factor. Yes or no? So it is said to be neither prime nor composite. And fourth point, fourth observation, any natural number greater than 1 and that is not a composite number is a prime number. This is another observation. Any natural number greater than 1 and that is not a composite number, then the number is said to be a prime number. Next point, every composite number has at least 3 factors. The composite numbers may have 4 factors or 5 factors or 6 factors, but at least 3 factors. Every composite number has at least 3 factors. And the next observation, 2 is the only even prime number. This point we have already learnt in earlier class. 2 is the only even prime number. And the seventh observation, we can divide the set of natural numbers into 3 disjoint sets as given below. That is the first one, singleton set 1, and this is prime numbers, and another one is composite numbers. Like this, we can divide the natural numbers into 3 disjoint sets. Disjoint means there is no common. For all these 3 collections, no number is in common. Okay, my children. Now come to the main
Okay.
point. Main concept of this period. What is that point? Different methods of finding prime numbers. You have already learnt for finding prime numbers from 1 to 100. What is used here? What is used in your earlier class to find the prime numbers from 1 to 100? Eratosthenes, sieve of Eratosthenes. Yes or no, my children? Do you remember that Eratosthenes, sieve of Eratosthenes? In that method, he is a famous Greek mathematician, suggested a method to find out prime numbers. It is called sieve of Eratosthenes. He is mathematician, Greek mathematician. He invented a method that is called sieve of Eratosthenes. This method helps us to find out prime numbers up to a given natural number. What is that method? Let us see that procedure. Write all the natural numbers from 1 to n. Whatever the number you required, up to that number you can write the natural numbers. Second, the first prime number is 2. Leave 2 and round off all the multiples of 2. They are 4, 6, 8, and so on. The next prime number left is 3. Round off all the multiples of 3 except 3. Like this, we have 25 prime numbers from 1 to 100 by using this method. How many prime numbers are there from 1 to 100? Do you remember? How many prime numbers are there between 1 and 100? 25 prime numbers are there between 1 and 100. Remember this point. And also, you have to remember that 25 prime numbers. Okay, my children. Now come to the next point. We have to continue this process up to the highest prime, which does not exceed square root n. We have to continue this process up to the highest prime, which does not exceed the square root of n. That is, first, what should we do? Find the square root of the natural number n. Okay, whatever the number is given, we have to find the square root of that number. Next, round off the result to the nearest integer. Let it be m. We have to round off that resultant number. Suppose that is m. Now, third step, verify whether n is divisible by all prime numbers less than or equal to m or not. Now, the important step here is we have to check whether the number m, this number m, is divisible by all the prime numbers less than or equal to this number m. Okay, my children. Right. Next, if n is not divisible by any one of the prime numbers below m or m itself, then it is a prime number, or else it is non-prime number. So we have to check all the prime numbers up to m. They divide the given number n or not. We have to check whether the given number is divisible by all the prime numbers less than or equal to m. If all the prime numbers less than or equal to m divide the given number, then the given number is said to be composite number. If any number does not divide, any prime number does not divide the given number, then it is called prime number. Understood this procedure, my dear children? So you have to follow
Yes,
this
sir.
procedure. Now let us take one example. Let us take an example by using this method. Let us check whether the given number is a prime number or not. Okay. See here. See this example. Verify whether 223 is a prime number or not. we have to check the given number is a prime number or not. First of all, we have to assume that given number is n, that is considered as n. Now we have to find square root of 223. It is approximately, this symbol stands for approximately equal to 15. Square root of 223. Actually, square root of 225 is equal to 15. Square root of 225. But the given number is 223. Square root of 223 value is nearly equal to 15. So we have m is equal to 14. Okay, less than this number. Okay, now prime numbers be less than 14. What are the prime numbers less than 14? See, 2 comma 3 comma 5 comma 7 comma 11 comma 13. These 6 prime numbers are less than 14. 14 is not a prime number. Yes or no? So below 14 we have written all the prime numbers. Now we have to check the given number 223 is divisible by 2 or not. You know divisibility rules. We have discussed divisibility rules in the bridge course. In bridge course for 9th class I have discussed bridge course. For you are also that point discussed in the bridge course, my dear children. Do you remember that point? Divisibility rules. By using that divisibility rules, we check whether the given number is divisible by 2 or not. Can you tell me anyone? 223 is divisible by 2 or not? Tell me. Anyone can tell this answer? 223 is divisible by 2 or not? Whether this number is divisible by 2 or not, 223. Can anyone tell the answer? My dear children?
No, sir.
Why it is not divisible by 2? Why this number 223 is not divisible by 2?
So because the ones plus the third can be 0, 2, 4, 6 or 8.
Very good, very good. That is the rule. That is the divisibility rule. In the given number, in the units place, in the ones place, there should be either 0, 2, 4, 6 or 8. Any one of these digits should be there in the units place. But in this given number, what is the digit in the units place? 3. So this number is not divisible by 2. Similarly, take that number 3. Is this number divisible by 3 or not? Can you tell me? Without doing the long division, by applying the divisibility rule, can you tell me anyone? Is it divisible by 3 or not?
No, sir, it's not divisible
Why
by
it is
3.
not divisible by 3? Can you tell me the rule? Divisibility rule?
So sum of all digits should be divisible
Yes.
by 3, sir. So
Yes,
2
very good.
plus 2 plus 3 is equal to 7 and
Yes,
7
sir.
is not divisible by 3.
Yes, very good, my dear. That is the divisibility rule by 3. So this number is not divisible by 3 also. Now come to the next prime number 5. Is this number divisible by 5 or not, and why? Tell me the reason also. Why it is not divisible by 5 or why it is divisible by 5? Anyone?
So units place is not ending with 5 and 0, sir.
Yes. In the units place, there should be either 0 or 5. Any one of the two digits 0 or 5 must be there in the units place, in the ones place. Otherwise, that number is not divisible by 5. Next number 7. We check by long division only. We check this number by long division. We have not studied divisibility rule by 7. By long division, by using the long division, we verify that it is not divisible by 7. Now come to the 11. Is this number divisible by 11 or not? Can you tell me? Anyone? Can anyone tell the answer? 223 is divisible by 11 or not, and why? Tell me the answer, my dear children. Is this number divisible by 3, 11? 223 is divisible by 11 or not?
No, sir.
Why?
Sir, I did long division, sir. It's not divisible by 11.
Okay. By using long division also, but without using the long division, there is a divisibility rule. Divisible by 11. Do you remember that one? We select one digit and leave the one digit, and we add the remaining numbers like this. Alternate numbers, we add alternate digits, and we add the remaining remaining digits, whatever we left. Then the sum of these numbers and the sum of the other numbers. Suppose, for example, in this number 2 plus 3, we leave middle number. 2 plus 3 is 5. Okay, only one digit is left here. 5 minus 2, what will you get? We have to find the difference. We have to find the difference of the sums got by adding the alternate digits. So here 5 minus 2, 3 only. So the 3 is not divisible by 11. Now we check by 13. Here 13. By long division, we check it whether it is divisible by 13 or not. If you check that number, you can say that it is not divisible by 13. So clearly 223 is not divisible by any one of the above prime numbers. Therefore 223 is a prime number. Understood this step, my dear children? Understood this procedure? How to check, how to verify,
Yes, sir.
a given number, whether the given number is a prime number or not. Okay, my dear children? Now,
Okay, sir.
let us take some examples. Let us take some examples. Are you able to watch the screen, my dear children?
No, sir.
Book, you are not
No,
getting
sir.
any. I will check. I will check it. Now, are you able to
Yes, sir.
watch the screen?
Yes, sir, we can.
Yes. What is this question, my dear children? Can you read this question?
Yes, sir.
Read.
Verify whether 116 is a prime number.
Yes, very good, my dear Kevin. Now,
Yes,
can
sir.
you tell me whether this number is a prime number or not, and why? Can you tell me this number is a prime number or not, and why?
Sir, it is not a prime number because it is divisible by 2.
Very good. Very good, my dear Jordan. Just by observing the given number. Very good observation, my dear Jordan. This number is an even number. It is divisible by 2. Yes or no? 116 is therefore 116. Now understood this point, my dear children?
Yes, sir.
Now let us take one more example.
Sir, should I write this, sir?
Yes, you can note it down. You can note
Will
it
you give it
down.
to the Google Classroom, sir?
Yes, I
Put
will
the
post.
page.
I will post these notes in the Google Classroom also. Don't worry. Don't worry, my dear children. I will post this classwork notes in the form of PDF in the Google Classroom by today evening, before 8 o'clock. Before 8 o'clock, I will post it. Okay? If you can write now itself, it is better. Otherwise, after posting that classwork notes, you can copy it in your.
Sir, page.
Yes, my dear. Maintain a separate classwork notes for this I.I.T.Foundation. Don't write these
Yes,
notes
sir, I
in
have.
your regular math classwork notes. Okay, my dear children. Please remember this point. Keep this point in your mind. Don't write this foundation classwork notes in regular math classwork notes. Maintain a separate classwork notes for I.I.T.Foundation. Okay, my children. Okay.
Yes, sir.
Now,
Write on the page, sir.
now check this question. Check or verify whether 117 is a prime number. Is it a prime number or not? Let us follow that procedure, my dear children, as we have discussed previously. Let n is equal to 117. Let n is equal to 117. Then what should we do? We have to find square root of 117. We have to find square root of 117. Do you find the square root of 117? Can you find the square root of 117, my dear children? By division method. Do you remember the division method? In the chapter squares and square roots, we will you will learn this point in the 8th class itself. In 8th class, you will study in squares and square roots. You will learn how to find square root of 117 by division method. Here, now just listen, my dear children, how to find square root of a number in this division method. Okay, we take a pair of numbers starting from right end. So units place and tens place, we take this as one group, and the remaining one digit is one group. Okay, like this we had to divide that a pair of digits starting from the right end. So for the last two digits I have kept a bar symbol, means that is one group, and the second group is 1. So first we take the first this one group. What is the nearest perfect square to this number? 1. Yes or no? So we have to take 1 perfect square number, nearest to perfect square number we have to find out. So nearest to perfect square number is 1 only. So 1 ones. Then we carry down the remaining two digits at a time. In a long division, generally we carry down only one digit. Yes or no? In long division, we carry down only one digit. Whereas in this division method, we carry down the next two digits at a time. That is 17. We carry down the next two digits at a time. Now we double this number. Just to add these two numbers, 1 plus 1, 2. We have to write here 2. And we have to keep a dash, a blank. Listen carefully this division method to find square root of a number, my dear children. Okay. So it is approximately root 117. It is approximately nearly 10. It approximately near 10. Square root of 117. Square root of 117. It nearly approximately. Okay, my children. Here after keeping that blank, here to keep 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, like this. You have to select one digit. If you write 2 after 0, you have to multiply 0. Then what will get 0. If you write after 2, if you write 1, we multiply by 1 only, 21. We get here 21. It is a bigger number. So we keep here 0, and here we also keep 0. So we get 0 here. Again we take the double of this number, 20. Okay, here no digit is there to carry down. Then we have to keep decimal point. We have to write 2 zeros, because in the division method I said previously we have to carry down 2 digits, but here no 2 digits are there. We have to carry down 2 zeros like this. Again we follow the same procedure. So it is approximately equal to 10. Root of 117 is approximately equal to 10. Now prime numbers, prime numbers less than less than 10. Less than 10. What are the prime numbers less than 10? Can you tell me what are the prime numbers less than 10? What are the prime numbers less than 10?
2, 3, 5, 7.
Yes or no, my children? Now we verify. Now we verify this number, whether it is divisible by 2 or not, whether it is divisible by 3 or not, whether it is divisible by 5 or not, whether it is divisible by 7 or not. Okay, here this number is not divisible by 2. Yes or no? Why this number is not divisible by 2?
Because it's not an even number.
Yes. Now come to the number by 3. Check whether it is divisible by 3 or not.
No, sir.
How do you say it is not divisible by 3? Don't use the long division. Don't use the long division. Without long division, can anyone tell the answer whether this number is divisible by 3 or not?
Sir, which number?
Divisible by 3 or not?
Yes, sir.
Previously, Jordan told that formula. Sum of the digits. What is the sum of the digits in this number? 1
Sir,
plus
9, sir.
9 is divisible by 3 or not?
Yes, sir.
So it is enough. At least any digit, any one prime number should divide. Okay, so 3 divides this number. So we can say that it is not a prime number. It is a composite number. Therefore, okay, my children, understood this procedure? How to verify, how to check whether the given number is a prime number or not. Okay, my children. Now verify. Let us take another example. What is this number, my children? Verify whether 9801 is a prime number or not. We have to verify that whether this number is a prime number or not. What is the first step? let us assume that given number is equal to n, 9801. After that, we have to find square root of this number by division method of what I explained here. You will learn this method in the squares and square roots chapter. Division method is there. Okay. By using the division method, let us find the approximate value, the nearest value of square root of 9801. See here. Previously I told you had take a pair of digits starting from the units place. So 0, 1 I took as one group. The remaining two digits I took as a one group. So 98, what is the nearest square number?
Sir, it is
What is the nearest square number, perfect square to this number 98?
sir, please move the book, sir.
What? Sorry?
Move the book, sir. It's not clear.
Uh, now is it
It's
okay?
okay. Yes, sir.
What is the, I'm asking here, I'm asking this part. 98 is there here. The first two digits is 98. What is the nearest square number? I will write here 1 square, 1, 2 square, 4, 3 square, 9, 4 square, 16, 5 square, 25, 6 square, 36, 7 square, 49, 8 square, 64, 9 square, 81, 10 square, 100. These numbers 1, 4, 9, 16, 25, 36, 49, 64, 81, 100 and so on. 11 square, 121. 12 square, 144. 13 square, 169. Okay, 121, 144, 169. These are said to be perfect square. Now tell me which perfect square is the nearest one. Which perfect square is the nearest perfect square to this number 98? 81. Yes or no? Nearest one. So 9 nines. We have to take that table. 9 nines are 81. Okay. Now subtract 8 minus 1, 7, 9 minus 8, 1. Now we carry down the remaining two digits, that group of digits. Now I take double of the digits, 9, 2s are 18. And I told you here we have to keep dash, as we have kept dash here. Here also we keep dash. After that we have to keep 0 in this place, 1, 2, like this we have to verify. Okay, my children. Okay, let us conclude this class. Now the time is 4 past 18 minutes. If you are interested, can you do this question, my children, by following the previous steps? Will you try this number? Can you check whether this number is a prime number or not? Will you do that one?
Yes, sir.
Try this question, my dear children. Okay. Now the time is 4 past 18 minutes. Now you can leave the meeting, my dear children. Stay at home. Stay safe. Sanitize your hands frequently. Maintain social distance, my dear children. I will post this classwork notes in the Google Classroom in the form of PDF. Please find it and write that classwork notes and submit. on time. This work, your classwork note submission, also considered for internal assessments. Okay.
Sir, can you turn the before page?
What, my dear?
Before page, can you turn, sir?
Sorry?
Sir, can you turn the page before?
Previous page.
Yes, sir.
These 4 lines, 1, 2, 3, 4, 5. These 5 lines.
Okay, sir.
Don't worry. I will post this one. Okay. I will
Yes, sir.
post this classwork notes in the Google Classroom in the form of PDF by tonight before 8 p.m. Okay. You can find it and
Yes,
write the
sir.
classwork notes. Okay, my dear children. No need to write the notes now itself. No need to write these notes now itself. Okay. Now you can leave the meeting, my dear children. All of you. All of you leave the meeting. No
Thank you,
need
sir.
to
Bye,
write
sir.
no need to write this classwork notes now itself. I will post this classwork notes in the Google Classroom. Don't worry. Now you can leave the meeting. Vivek, John, B, David, Angel, Lavani, Mesh.
Thank, thank you, sir. Bye, sir.
Thank you, and bye. Lavani, John B, David, Angel. Still you are online. You can leave the meeting, my dear. I'm closing these notes. I will post these notes in the Google Classroom. Don't worry. आप जैसा పెట్టాను కార్డ్ పెట్టాను కానీ ఆపేసా ఆపేలా John B. David and Angel, still you are online? Why are you staying back? Still online? John B. David, John B. David, Angel, leave the meeting. John B. David, still you are online?
వస్తుంది కదా. ఇది వస్తుంది కదా. రైట్ చేయి హ్యాండ్, రైట్ చేయి హ్యాండ్. అదిగో ఇక్కడ. నువ్వు స్టూడెంట్ ఏంటి రావట్లా? మైక్లో చెప్పు, మైక్లో చెప్పు.
David, why are you staying back still online? Why are you not leaving the class? John B. David. David.
అమ్మయ్య ఇప్పుడు వెళ్ళిపోయాడు వాడు.